All right, let's work on number 5 on page 3. Okay, first things first, what is the given value in the problem? That's what's given to you. So let's start there. Let's write that first. That's 200 grams of C2H6 chemical, okay, or a molecule. We're going to need to calculate the moles of CO2 formed. So I'm going to circle that. I'm going to say, or I'm going to write equals that. This is where my last final answer should be and what it should say, moles of CO2. It should only have the units of moles of CO2. Okay, so we need to convert from C2H6 to moles of CO2. We need to connect to this chemical reaction. How do you mean, or what do you mean? Well, this is in moles. So what this is saying is for 2 moles of the C2H6 chemical or molecule, plus 7 moles of the O2 chemical, you can create 4 moles of the CO2 chemical and 6 moles of the H2O chemical or molecule, okay? What's important to note is the two things that we're looking at, C2H6 and CO2. So how you should see this from this chemical reaction is for every 2 moles of C2H6 chemical, you will create 4 moles of the CO2 chemical, 2 to 4 ratio. For every 2 moles of C2H6, you create 4 moles of CO2. We like that relationship, and we want to get from here into this relationship somehow. By the way, harping on this, think about it. For every 2 moles of C2H6, I create 4 moles of CO2. Imagine if I had 4 moles of C2H6. Not just 2, but 4. Let's just imagine for a second you have 4. How many CO2 moles would we create? Judging from this ratio, 2 moles of C2H6 create 4 moles of CO2 chemical. If I had 4 moles of C2H6, which is twice as much as what we see here, you would create twice as much, which is of CO2, which is 8 moles of CO2. I don't know if you were able to follow that, but basically, we want to get to this relationship, all in moles. What we have, however, are grams of C2H6, okay? We need to convert that first into moles of C2H6. We want to see how many moles of C2H6 this is, 200 grams is. Okay, we need the molar mass of C2H6. Conveniently, it's right here. Normally, you would have to calculate the molar mass of C2H6 using a periodic table. But for this problem, you didn't have to, okay? There it is, 30.1 grams per mole. What this means, if I could expand on that, is for every 1 mole of C2H6, that weighs 30.1 grams of C2H6. Sorry, let me move this over just a little bit. You could also write this ratio, or this conversion factor, where you flip the numerator with the denominator. So meaning 1 mole of C2H6 can go on the top, and on the bottom is 30.1 grams of C2H6. They both mean the same thing, but the order is different. They're flip-flopped. The question is, I'm going to multiply this to one of these conversion factors. The question is, which one? This one or this one? The answer will actually be this one. Let me write that down and then explain why. Okay, so why did I choose this version? Okay, the reason why is we want our answer to only have units of moles of C2H6 because we're trying to get this into moles of C2H6. That means we need to get rid and cancel these grams, this unit of grams G C2H6. The way I set it up ensures that that will happen. The reason why is because 200 grams of C2H6, the way it's written, if you multiply it by a fraction where grams of C2H6 occurs or is written on the bottom, they will cancel out. It's sort of like this old algebra, like this. What if I multiplied 5 times, let's say, 21 divided by 5? Did you know that the way I wrote it like this, 5 times 21 divided by 5, these 5s would actually cancel out. Why? Because if I multiplied this out, this would be 5 times 21 divided by 5. Now do you see it? The 5s clearly cancel out. It's the same number on the numerator as it is on the denominator. But I like this version right here. And this applies to units. Grams of C2H6 times that with grams of C2H6 on the bottom, they perfectly cancel out. Okay? Let's erase this just really quick. I'm erasing some other stuff off camera right now to make space for what I'm about to say. Okay, if I stopped right here, this would give me how many moles C2H6 do I have from 200 grams. Let's just do that calculation. Just kind of offhand right now. Okay, let's do 200 times 1, or 200.0 technically, times 1. And that's dividing by 30.1. Okay, 6.64. What does that mean? That means if I did this multiplication out and I only have these units left, that's how many moles of C2H6 I have, 6.6. But that's not the final answer. I'm looking to see how many moles of CO2 could I make from my moles of C2H6 I have. So this isn't enough if I stopped right here. I need to keep converting so I can go from moles of C2H6 into how many moles of CO2 I can make. So what I'm going to do now, like I said in the beginning, is I'm going to resort back to this chemical reaction, that ratio. For every 2 moles of C2H6, I can create 4 moles of CO2. Let's write that as a fraction or conversion factor ratio. For every 2 moles of C2H6, I can create 4 moles of CO2. I can also write that in a slightly different order, where I could put 2 moles, instead of 2 moles of C2H6 up here, I could write it on the bottom. 2 moles of C2H6 on the bottom with the 4 moles of CO2 on the top. My question is, which version do I use to multiply into here? Is it this version or this version? I'm going to tell you right now, it's this version. Let's go ahead and write that, and I'll re-explain once again. 4 moles of CO2 on the bottom and 2 moles of just C2H6 on the bottom. I'm sorry, 4 moles of CO2 on the top. Sorry if I misspoke. Okay. Why? Because if I multiplied this, which again, if I stopped multiplying, that would have been 6.64 moles of C2H6. That unit is in moles of C2H6. I want to get rid of that unit. This way, the way I wrote it with the 2 moles of C2H6 on the bottom, ensures when I multiply this to this, that this and this will cancel out. They're the same unit on the top and the bottom. Okay? Just like kind of how I explained here when I whited it out, before I whited it out. You will have a unit left over only after all this canceling of units. The only unit that I have left over is moles of CO2. And guess what? That's what I wanted. That's what this question was asking for. That's what I left a space for. Because I want, this ensures that all my math is set up correctly. Okay? Okay. The last thing to do is to calculate all this math. It's pretty simple. What you're going to do, it's not easy, but it's not super complex. Ah, man, I am having a hard time with my camera. Okay, it's 200. You take that first number and you multiply it to the top numbers in the fractions or conversion factors, 1 and 4. So let's go ahead and do that. 200.0 times 1 times 4. Then I can press enter, and then whatever number I get, I divide it by 30.1, and I divide it by the other number in the denominator, 2. But you know what? I could put that all in one entry on my calculator. Let's go ahead and do that. So the next step was not only to multiply this number, this, and this at the top, but to divide it by 30.1. So let's go ahead and press that on my calculator, divided by 30.1. And the next step is to divide whatever that product would have been by 2. So I'm going to put that on my calculator, divided by 2. Let's press enter. I got 13.28, which rounds to about 13 point, I'll say 3. 13.3 moles of CO2. And that's it. That's the final answer.